Hi, I'm Carl. In this video we're going to have a look at questions 12 to 16 or Unit 4 of Section 3 of the Blue Booklet. This is a question by salmon and how their oxygen uptake can change at different temperatures and at different speeds. It's useful to have these figures beside you as we go through these questions. And we'll start off with question 12 then. It says for figure 1a, oxygen uptake increased with speed y. So let's go through the different answers. For figure 1a, and there's no change in water temperature, so we can rule out A. We're told that it's going to be 15 degrees C for that particular graph, so it's not going to be A. B says the fish used anaerobic respiration. If the fish used anaerobic respiration, you'd expect a drop in the oxygen uptake, not an increase, so it's not going to be B. C says the metabolic rate of the fish changed. Well, as it keeps swimming faster, we're told that it needs to put in more effort until it reaches this sort of terminal or top sustainable speed, and if it's putting in more energy, it's going to need more oxygen, so the metabolic rate must have changed. So the answer for this one is going to be C. But to rule out D, it says gas exchange occurred at organs other than the gills. From the information we're given, I don't think there's any reason to think that that's taken place, so the best answer for this one is going to be C. 13 says, according to figure 1a, which one of the following is the best estimate of how many milligrams of oxygen is taken up in 5 minutes by a 100 gram salmon swimming at 60 meters per second. So the tricky one about this is the units, so pay attention to that. So at 60 centimeters per second, we can see that the uptake is going to be around 500. But of course this is going to be kilograms, it's going to be milligrams per kilograms per hour. And we know that we're dealing with a 100 gram fish for 5 minutes. So we could change this to 50 milligrams per 100 grams per hour if we divide it by 100. And then if we want it in 5 minutes, then we can divide by 12, because there's 12 lots of 5 minutes in an hour. So if we divide this by 12, we can get 50 over 12, which is going to be roughly 4. And so the best estimate in this case is going to be B. If we look at question 14 now, it says which one of the following is the best estimate of the speed corresponding to line 3 in figure 1b. So if we look at figure 1b, line 3 says, well, first of all, we need to realize that figure 1a is at 15 degrees Celsius. That's given in the question. So if we go across to figure 1b and have a look at what its oxygen uptake at 15 degrees Celsius is, we can compare that to figure 1a and get an idea of the speed. So at 15 degrees C, line 3 is roughly around 300. I'm getting from the graph, of course, just an estimate, and I don't think it's that accurate, but I think around 300 is okay. So then if we go to the figure 1a and we have a look at an oxygen uptake of around 300, that would correspond on that line to a speed of about 40 centimeters per second. So the best estimate we can get here is going to be 40 meters per second, or B. So 14 is also going to be B. 15 says, which one of the following helps explain why for line 3 oxygen uptake at 20 degrees C is greater than at 10 degrees C? So what's changing between 10 degrees C and 20 degrees C? So let's go through the different answers here. A says that the fish swims faster. That might be the case, but I don't think it explains why the oxygen uptake would be greater at different temperatures if they're swimming at different speeds. There's no reason to think that they'd swim at a different speed at a different temperature. So it's not going to be A. B says anaerobic respiration is greater. This is quite similar to question 12. If there was anaerobic respiration being used, you'd see a reduction in the amount of oxygen being taken up. So it's not going to be B. C says more energy is needed to achieve the TSS. Again, there's no indication of the speed that the fish is swimming at this graph. And there's no reason to think that the energy requirement to reach the TSS would be different at different temperatures. So that leaves us with answer D, which is feasible, which says more energy is used for activities other than swimming. If it's using more oxygen, then it must be respiring more, and it's using energy for something other than swimming in that case. So that means that the answer for 15 has to be D. And then finally, we've got question 16, and I've copied out the equation here, and I'll just rub this out so we can have a bit more room. So we are asked for line 5 of figure 1b, QW is greatest when X is the temperature corresponding to what? So to make this fraction as big as possible, you want to increase the numerator or decrease the denominator, ideally both. So in order to get the greatest value of QW, you're trying to find really the biggest difference between these two metabolic rates. So metabolic rate, of course, is going to be proportional to the amount of oxygen being used. So if we look at figure 1b, line 5 is really just showing us a line of the metabolic rate against different temperatures. So let's compare these points. So they're coming in pairs, and we know that the temperature difference here is comparing it at one temperature and then another temperature that's 10 degrees less than that. Going through all the different options, then A says L, the temperature corresponding to L. So if we compare the temperature at 10 degrees C and 0 degrees C, we see there's not that much of a difference. And again, we're really just trying to find the difference, the greatest difference between these 2 points in order to maximize our value of QW. So L doesn't really give us a very large value for QW. If we look at M, then we're going to be comparing the difference between the metabolic rate at point Q and point M, because they're 10 degrees Celsius apart. And we can see that is the portion of the graph with the greatest change in metabolic rate over that temperature range. So at the minute, that one is going to be our answer. If we look then at N and L, comparing those two, we can see there's still quite a big increase in metabolic rate, but it's not as big as we had before, so B is still our best answer so far. And then if we look at answer D, we need to compare points M and P. And because P is actually smaller than M, we're actually going to get a value of QW which is less than 1. So that means that out of all those options, the biggest value for QW is going to be the temperature corresponding to point M, or in this case that'll be answer B. So that was questions 12 to 16, or unit 4 of the third section of the blue booklet. I hope that helped. Thanks for watching.